Hello students, this video is about second kind of projectile motion, that is a projectile when given angular projection. So here we have a projectile that is fired with a velocity u and making an angle theta, this angle theta with the direction of horizontal. So the projectile that we are going to study now is a projectile given angular projection, have initial velocity u and is projected at an angle theta with the horizontal. So let a body is projected with initial velocity u making an angle theta with horizontal. If the situation is like this, then the initial velocity u can be resolved into two rectangular components. One is along horizontal and the other one is along vertical, that is u cos theta and u sin theta. So the velocity u has two rectangular components. First is u cos theta. This u cos theta is the horizontal component along x axis, and second is u sin theta, that is vertical along y axis. Also the horizontal component, that is u cos theta, remains constant throughout the motion. So this component remains constant throughout the motion, while the component u sin theta changes with time because of the effect of gravity. So this component, the component u sin theta, first decreases as the body is moving upwards, which is against the gravity. So the component u sin theta first decreases till the point it becomes 0 at maximum height. So the point at which this u sin theta component becomes 0, that is the maximum height attained by the projectile during its motion. In our diagram it is represented by point A, and after that it again increases till the point projectile hit the ground. So first it decreases up to point A and then it increases up to the point where projectile hits the ground, right? So u sin theta first decreases, then 0 at point A, and then increases after point A till the ground. ये हमें ध्यान रखना है. So now under the combined effect of both components u cos theta and u sin theta, the body that we have projected, means the projectile that we have, it follow a parabolic path that we are showing here by the trajectory OAB. So this is the trajectory of the projectile. The parabolic path that is represented by OAB is shown by the projectile. So same as the previous video, we have to find the components, equation of the trajectory, time in which the body attains maximum height, time of flight means the total time during the trajectory, the maximum height means this distance that is attained by the projectile, and the horizontal range means the horizontal distance during the time of flight. So all these points we have to find. First of all, we are starting with the equation of trajectory of parabola. Shaped projectile motion, that means we have to find the equation of trajectory of a parabolic path traveled by projectile, or we can say that the projectile is attaining a parabolic trajectory and we have to prove that the trajectory that is attained by the projectile will be parabolic. This we have to show, and for that we have to find the equation, the relation between y and x, such that y is a quadratic function of x. So let's start. First of all, we suppose that at any instant t, p is the position of the projectile and its coordinates are x comma y. So at any instant t, projectile reach at point p x comma y. So for this point, the horizontal distance covered by the body is x and the vertical distance covered by the body is y. So in time t, horizontal distance, this is in time t, horizontal distance covered by the body is equal to x, and it is given as horizontal distance is equal to horizontal velocity into time. That means x is equal to u cos theta, which is the horizontal velocity, and time t. So we can write that the time is x upon u cos theta. This is the time that is taken by the particle to reach point capital P. Now for vertical motion, vertical distance, or for vertical motion we have to find the distance y. For vertical motion, distance is y, and that we have to find. For this we will use equations of motion, and the equation that we are going to use is second equation of motion. So s is equal to ut plus half at square का हम यूज करने वाले हैं. For the vertical motion, u is equal to, means initial velocity, initially for vertical motion the velocity is u sine theta, and acceleration is, since the motion is upward, vertically upward, so acceleration is minus g. So let's substitute all these values. We can find y by substituting these. Y is equal to u sine theta into time is x upon u cos theta plus half minus g, and time is again x upon u cos theta ka whole square. When we solve this, we get y is equal to x tan theta, sin theta upon cos theta is tan theta, minus g upon 2 u square cos square theta x square, and we can consider tan theta and this term as some constants p and q because these are fixed. So we write it in the form px minus qx square, where p is equal to tan theta and q is equal to g upon 2u square cos square theta, means p and q are constants basically. If it is like this, so y is a quadratic function of x, and this shows that the trajectory of the projectile that we are trying to find is parabolic and is given by the equation y is equal to px minus qx square. So parabolic proof करने के लिए we need that y is should be a quadratic function of x that we get here, so the trajectory is parabolic. Next thing that we have to find is the time of maximum height. So for time of maximum height, here we have point A is the maximum height point. So we want to find the time in which projectile moves from O to A. This time we have to find, and during this time, at the highest point, when that projectile reach at the highest point, its velocity becomes 0. At highest point the velocity becomes 0. This fact we have to use to find the time of maximum height. So let this time of maximum height is represented by t and suffix में m. So tm represent the time of maximum height, that means in which projectile reach from O to A as per our diagram. At A means at the highest point, the velocity of the projectile is 0. Final velocity is 0. If we talk about initial velocity, so initially the vertical motion of the projectile is because of the vertical component of velocity, that is u sine theta. So for achieving the height, the component of initial velocity that is responsible was u sine theta. So we have initial velocity, we have final velocity, we have acceleration, that is minus g. Now acceleration is minus g because the object is moving upwards, that is against the direction of acceleration due to gravity g, which is downwards. So by applying the first equation of motion, v is equal to u plus at, we can find the time. So v is equal to 0, u is u sine theta plus minus g, and the time is tm. So we get tm is equal to u sine theta upon g. So this is the time in which projectile attain its maximum height. This is the required time. Now if we want to find the time of flight, for time of flight, so time of flight is the total time in which body attains maximum height, means time for O to A plus then time for A to B, means the time taken by the body from maximum point to maximum height point to the ground. So we want the total time in which body have thrown and it reached the ground, that total time. Now this total time is actually equal to the twice of tm. The total time is equal to the twice of tm, because ऑब्जेक्ट को जितना टाइम मैक्सिमम हाइट तक जाने में लगेगा उतना ही टाइम उसको वापस ग्राउंड पे आने में लगेगा. सो दिस इज tm and this is tm. So the total time means time of flight is actually 2tm, that is 2u sine theta over g. But we are going to prove it using equation of motion also. So time of flight is the time taken by the projectile from instant it is projected to the instant it reach a point in horizontal plane of projection. जिस प्लेन से उसको प्रोजेक्ट किया है वहीं पे आके हिट करे, horizontal plane of projection. That total time is called time of flight and it is represented by tf, that is capital T suffix f. Now vertically अगर हम चेक करें, so the net displacement by the projectile during the time of flight is 0. Since ये vertically यहीं से start हुआ, इसी plane से start हुआ and again it come back to the same point. So net vertical displacement for the projectile in time of flight is 0. Net vertical displacement during time of flight, that is tf, is equal to 0. So by using second equation of motion, s is equal to ut plus half at square, we can find tf. So s is 0 when t is equal to tf. S is 0, u is u sine theta because we are taking vertical displacement, t is tf plus half, acceleration is minus g because vertical motion is there, and tf is square. So on solving this we get u sine theta into tf is equal to g by 2 tf square, which implies tf is equal to 2u sine theta over g. So that is 2tm, twice of the time taken by the projectile to reach maximum height. So time of flight is the twice of time taken to achieve maximum height. Or we can also say that the time of ascent is equal to the time of descent, means projectile का ऊपर जाने का time, ascending period और descending period are same, and in both cases the parabolic path is symmetrical. It will attain a symmetrical parabolic path during its motion. So this is about the projectile when given angular projection. Now 2 points are remaining. One is the maximum height that it achieve, means the distance hm, and next is the horizontal distance, means horizontal range achieved by the projectile. Let's see. So maximum height of the projectile is the maximum vertical distance. It is the maximum vertical distance attained by the projectile above the horizontal plane. Which horizontal plane? So this is the horizontal plane from which it is projected. We can also write it as horizontal plane of projection, and we represent this maximum height as hm. So now we have to find the distance hm. It is like this. We have to find the distance, this a, the distance of a from horizontal plane. So at highest point, we know that the velocity is 0. At highest point a, the vertical component of velocity is 0, and initially this vertical component, initially it was u sine theta. So we know the initial velocity and final velocity, and from third equation of motion, that is v square minus u square is equal to 2as, we can find the distance s. So v is 0, u is u sine theta square is equal to 2, acceleration is minus g hm. On solving this, we get hm is equal to u square sine square theta upon 2g. So this is the maximum height attained by the projectile during its flight or during its motion. Next point that we have to find is horizontal range, and we represent it by capital R. So this is the horizontal range, means the total horizontal distance covered by the projectile. So horizontal range is the horizontal distance, horizontal distance traveled by projectile during its time of flight, means during time tf. The horizontal distance is capital R, and simple relation to define this is horizontal range, or this horizontal distance is equal to horizontal velocity, which remains same throughout the motion, into time taken, and that time taken is tf. So it will be horizontal velocity is u cos theta, and value for tf is 2u sine theta upon g. So we can solve it and find r is equal to u square. 2 sine theta cos theta is sine 2 theta upon g. So this is the value for horizontal range of the given projectile. So that was all the components to define a projectile motion given angular projection. That's all for this video. Next, the remaining part of this chapter is uniform circular motion that we will study in the next video. For that, stay tuned and keep studying. Thank you.